Yes, good evening to you all. We'll have circle chapter class today. With the discussion about the previous properties and all, we have done many questions based on the theorem statement, axioms and all. Few more questions left in this chapter. Today I will conclude this chapter. Okay. And tomorrow in my Sunday interaction class, 4 o'clock, you have the revision of number system. Okay. Get ready with the number system chapter. We'll have a set of questions discussion during that session. Okay. So now we'll start the question number 1. I didn't prepare any question paper or worksheet. Take the question. These are all questions from the textbook, some questions. So I'll give the question, take it down, then we'll have the answer. Okay? Very important condition here. Take the question number 1. If two intersecting chords, if two intersecting chords make equal angles with the diameter passing through their point of intersection prove that the chords are equal. Prove that the chords are equal. In the example question, its converse is given. If two chords are equal, then prove that angle between the two chords intersection is equally inclined to the line from the center. Instead of line from the center, they have added here, that is diameter passing through the center of the circle. So go through the question and you guess what is given, what you have to find it out. It is given two chords are intersecting each other. Inside the circle, two chords are intersecting and the line passing through the point of intersection, which is the diameter of the circle, are equal, then the chords are equal. The same figure with the converse we have proved earlier. Now we have this question. Okay? Take the question. And so take the question and below the question get the figure. This is a circle where the two chords are intersecting like this and making equal angles with the chord and the line which is passing through, that is the diameter. If they are equal, Then we have to show the chords are equal. Get the figure. OM and ON are perpendiculars. Angle 1 equals angle 2. We have to prove AB equals CD. Get the figure. Here the line which is a diameter to the circle is passing through the intersecting point. The point of intersection, I will take it as point P. Then in such condition, if they make equal inclination, then the chords are equal. Is clear? Then the chords are clear. Okay? Please check it once. It's already clear. I am seeing that in my mind. Okay, na? It is given AB and CD. They are not equal. We have to prove it is equal. AB and CD are two chords intersecting at a point P. And the line which is a diameter passing through the center make equal inclination. That means these two angles are equal. We have to prove AB equals CD. To show AB equals CD, here we have to prove they are equidistant from the center. As the property of the circle, chords which are equidistant from the center are equal in measurement. So we have to prove OM equals ON. Just to see the figure here in triangle MOP, NOP, OMP and ONP each 90 degrees and angle 1 equals angle 2, it is given in the question, and OP equals OP is the common part for both the triangle. Then by AAS congruency, two triangles are congruent. When they are congruent, then we can consider OM equals ON. When OM equals ON, therefore AB equals CD, because chords which are equidistant from the center are equal in measure. Is it clear? Its converse we have already done. That is, if chords are equal, then we have proved angle 1 equals angle 2. Now today we are proving if angle 1 equals angle 2, then AB equals CD. It is not ASA, it is AAS, angle. Because side angle means the side should include two angles. It's not included with the side. Two separate angle with the common side. So we consider that congruency as AAS. Okay? Get the steps to this problem. Question is here. Figure are given. Now write. Given a circle CO, R in which AB and CD are two chords. Here we are not mentioning two equal chords. They are just two chords intersecting intersecting at point P. Also, diameter makes equal inclination at point of intersection. If it is not possible, if you feel it is difficult, you can also mention and angle 1 equals angle 2. That is also okay. To prove, what we have to prove? AB equals CD. That is, they are equal chords. Construction, draw OM perpendicular to AB and ON perpendicular to CD. These are the two perpendiculars from the center. Perpendiculars from the center bisects the chord. If the perpendiculars are equal, the chords are equal. Like that, there is a interrelation with the chords, with the perpendiculars, with the angle, inclination, everything. So we have to go back to the statement every time so that there won't be any further confusion. So proof. I will write the proof here because there is no place here. Okay? Because question you already taken, I will write the proof here. What is the proof here? Proof. In triangle MOP and triangle NOP, angle OMP equals angle ONP. What is the reason you have to write? Each 90 degree. Angle 1 equals angle 2. It is given. OP equals OP. Common. Therefore, by yes, congruency, triangle OMP is congruent to triangle ONP, which implies AB equals, which implies OM equals ON. Therefore, AB equals CD. In the bracket, write the reason. Equal chords. I will write another reason. Chords which are equidistant, from the center are equal. We have alternate statement. Equal chords are equidistant from the center. Conversely, chords which are equidistant from the center are equal in measure. Go through it again. Over. Again, now I will go back to exercise question. Exercise 10.4, fifth question and sixth question. Statement itself is very lengthy, so that is the reason I am mentioning question number 5, exercise 10.4. Later you can go through that. Based on that figure I am going to draw here, but question is in the textbook itself. Okay, na? Here they have given picturized the condition that three girls, Reshma, Salma, Mandeep, two girls and one boy, are playing a game by standing on a circle of radius 5 meter drawn in a park. Reshma throws a ball to Salma, Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meter each, what is the distance between Reshma and Mandeep? Actually, this is active based question. Active based question, exercise 10.4, question number 4. Question number 5. So now, based on the statement or the problem, I will give the figure. Draw a circle of radius, any radius, not necessary you have to draw 5 centimeter circle. Actually, what I said, the teacher in the school should do the activity so that the child can get the concept of chords condition properly. So this is the figure. Get the figure properly. Draw a circle and take 3 points. They are Reshma, Salma and Mandeep. So I will write Reshma as R, Salma as S, Mandeep as M. This is the center of the circle. The center of the circle has a radius 5 meter and each of them friends are 6 meter apart from Reshma to Salma, Salma to Mandeep, 6 meter. Take the figure and we need to calculate what is the distance from Reshma to Mandeep. To that, join the center to the point S and join O to R. Five meter. If it is x, it is 5 minus x because OS, OR are the radius. So if I take this part, I will take this point of intersection as P. If it is x, the leftover portion will be 5 minus x. One property you should keep in mind, line from the center is perpendicular to the chord. We are considering line, that is OS is the radius. So the radius, when it proceeds, it will become a diameter. Now OS is perpendicular to RM. Then only we can consider two right triangles OPR and RPS. Okay, na? With the property. If you want, you can join the other part also, like this. Or else by the congruency also you can prove OR and OM are the radius of the circle. If you draw a perpendicular OS, that is it is bisecting the chord, then right angle hypotenuse side two triangles are congruent, then PR equals MP. They are half of the total chord. If you get RB into 2 gives RM, that is the distance between Reshma and Mandip. So take the figure properly. What over? Okay. Given a circle COR, a circle with center O, radius R, where R, S and M are the position of 3 students, or you can name them such that RS equals SM equals 6 meter and OR equals OM equals 5 meter radius of the circle. So what is given? I am clearly mentioning, that is 3 girls they mentioned. 3 students naming Reshma, Salma and Mandip are standing each other such that the distance between Reshma to Salma and Salma to Mandip is 6 meter. We need to find out what is the distance between Reshma to Mandip. Okay, na? And here the radius, that is from the center, it is passing through that point of intersection is P. Actually, we have to prove a congruency, that is showing ORS, OMS are congruent. Then later we have to prove these two are congruent. It's such a big process like that. We can have now here the radius from the center is bisecting, it is perpendicular to the chord. When it is perpendicular to the chord, we know that it is bisecting the chord. Directly we can write given to find RM, that is distance between Reshma and Mandip. Now, construction Draw instead of draw you write join OR, OM and OS. Okay, check it once. Further, OS is perpendicular to RM, therefore RP equals MP. Perpendicular line bisects the chord. We also proved in the earlier classes the point of intersection of the two circles is bisected by the common center, that is the line segment joining their centers. Like that, here we can have OS is perpendicular to RM, therefore RP equals MP. If you find out RP, then the distance between Reshma and Mandir can be calculated into 2 gives RM. So how to find out RP is the question. Here we consider two right triangles. Which are those? Right triangle ORP and right triangle SPR. Till I complete, just listen and observe my working. Later you can go through and write the notes. Okay? Just see. Don't give any answer. I didn't ask which theorem, what to do. Let others also see the board. Many times, every day I am repeating it. So now consider, in right triangle, here I have taken total radius is 5 centimeter. If part is x, the other part will be 5 minus x. Already I have shown. That is OP equals x, then SP equals 5 minus x. You can check the figure in your book. In right triangle ORP, when it is 90 degree, OR square is the hypotenuse, PR square plus OP square. OR square is 5 square minus x square equals PR square. That is 25 minus x square equals PR square. Take it as result 1. So figure I have covered. You have to check the figure from your book. I have taken a right angle triangle, keeping PR in the RHS, transferring, we get 25 minus x square equals PR square as condition number 1. Another right triangle. In right triangle RPS. In right triangle RPS, RS square equals PR square plus PS square. RS is 6 square, PS is 5 minus x whole square equals PR square. Okay, take it as result 2. So in result 1 and result 2, what we are observing, which is the common here, RHS are equal, right? See the equation 1 and equation 2, what we are getting? In equation 1 also PR square, in equation 2 also PR square. So from 1 and 2 we get 25 minus x square equals 36 minus 5 minus x whole square from the result 1 and Okay, can't you see this? Are you all seeing it properly, board? Yes. 25 minus x square equals 36 minus expand a square minus 2ab plus b square. Next, 25 minus x square equals 36 minus 25 plus 10x minus x square. Expanded. Now minus x square cancel. 25 equals 11 plus 10x. 10x equals 14. Therefore, x equals 1.4. So, now we have x value. Substitute to the equation 1. What is equation 1? 25 minus 1.4 whole square equals PR square. 25, 14 square is 196. So 1.4 square is 1.96. Therefore, PR equals root of 10 minus 6, 4, 0, 3, 2, 3, 23.04. So, square root of 23.04 is 4.8. Therefore, RM equals 2 into 4.8, 8 to the 16, 9.6 meter. That is, distance between Reshma and Mandip is 9.6 meter. Is it clear? Again, I'll go back to the figure. See the figure. Here, R, S and M represent position of Reshma, Salma and Mandip. Reshma and Salma and Mandip are 6 meter apart and the radius of the circle is 5 meter. When I join, RM gives distance between Reshma and Mandip. And the total OS is the radius. If I take this part as x, the left over will be 5 minus x. Here comes two right triangles. Why these are right triangles? The radius drawn from the center is perpendicular to the chord. When it is perpendicular, it is bisecting the chord. That concept you have to keep in mind. Later, we have the calculation. See the calculation and complete it now. Over. I hope everybody is able to see the board. Any confusion you can ask, I will explain it. Okay, na? Completed? Once again, I will explain why OS is perpendicular. When it is perpendicular, it is bisecting, it is perpendicular, then only we can get the two right triangles. Okay? Yes. See the figure. In this figure, OR and OM, they are the radius of the circle. RS and SM, they are equidistant from each other, each 6 meter. OS is common. So, two triangles are congruent by SSS. When they congruent, then we can consider ROS equals MOS. Again, consider triangle ROP and MOP. Here OR equals OM, they are radius. ROP equals MOP, we just proved. OP is common, two triangles are congruent. When they congruent, RP equals MP as CPCT. CPCT means again these two angles will be equal. So this becomes perpendicular. So in general, what we consider, the radius from the center bisects the chord perpendicularly. That will be the bisector of the chord RM. Based on that, we got two right triangles. Instead of showing the congruency proof, directly I took it as the right triangle condition. With the reason, radius from the center is the perpendicular bisector to the chord. How it is perpendicular bisector? Suppose somebody asks, you have to explain by SSS, these two triangles are congruent. When they congruent, these two angles are equal. That is ROS, MOS. Later we consider ROP, MOP. When they are congruent, again we get RP equals MP, angle RPO equals MPO. When they are congruent, we consider its corresponding parts. After going with the congruent triangles, again if I explain, that will be better. That is the reason I just taken out the property, that is radius from the center is the perpendicular bisector to the chord. When it is perpendicular, it bisects. When it is median, it must be perpendicular. Based on that, I took the property, the radius is perpendicular bisector to the chord. Here chord is distance between Reshma and Mandip. Is it clear to everybody? And using the condition, again you consider two right triangles applying Pythagoras theorem, keeping PR as the common either in LHS and RHS. Then we are comparing, you will get the value of x. Later substituting x in either in equation 1 or equation 2, you will get the measure of PM into 2 gives the measure of RM, that is distance between Reshma and Mandip. Okay, na? Next question. There is one more statement question in that exercise. So far in exam and all they won't give, but as an activity based in the practical class, you may have this type of question for a practical work. That is the reason I included at the end of this chapter. Okay, don't bother. This is question number 6, exercise 10.4. Question number 6, exercise 10.4. Next, get the figure. Here, a circular park of radius 20 meter is situated in a colony. 3 boys, Ankur, Sayyad and David are sitting at equal distance on its boundary, each having a toy telephone in his hands to talk each other. Find the length of the string of each. When they are situated at equal distance, then what type of triangle you will get? What type of triangle you will get? It will be what? Yes, it will be an equilateral triangle. 3 boys, they are sitting apart on a colony of a circle with radius 20 meter. Get the figure? For only 19-15 students, I can take it home only instead of doing this online classes, because many of them are regularly irregular to the classes. I will drop them from the tuition. If they are not coming properly, no use of shouting here in no empty class. So I call upon those who are very regular. That is the best thing I can do. Monish is present today. Monish. Rachana. Monish. Rachana. Maulia TR. See. Okay. See the code figure. I will explain. Yes, Aishani. Yes, just see the figure. ASD is an equilateral triangle because A, S and D are 3 students or 3 friends. They are having a toy telephone with placing an equal distance on a circular boundary in a colony with radius 20 meter. And we consider an equilateral triangle, altitude of an equilateral triangle is root 3 by 2 A. And altitude, listen the explanation, don't send any message now. Altitude of an equilateral triangle bisects the base. So when we consider A as the side of an equilateral triangle, when I say stop, please don't send any message. Listen the explanation. AD is the altitude of an equilateral triangle. It has the property in an equilateral triangle, altitude bisects the base. All those properties you are going to prove in the chapter congruent triangles. Here just consider the properties only. So when we consider A as side of an equilateral triangle, then DS will be half of the side of an equilateral triangle. All these are very necessary. Listen the explanation properly. And AD equals altitude of an equilateral triangle. Don't write anything, listen the explanation. Equilateral triangle. And altitude of an equilateral triangle bisects the base. Therefore, SD will be A by 2. AS will be A unit. Okay, na? Next, H equals root 3 by 2A. This is the formula we use to find the altitude of an equilateral triangle. In Heron's formula chapter, you are going to study how this formula and all comes. Now just consider it is root 3 by 2A. Okay. Next. In right triangle, OS square equals OD square plus SD square, where OS is 20 square, OD we can take it as AD minus OA whole square plus A by 2 whole square. Just see, don't take anything. Now 400 equals AD square. AD square, it is an altitude, so I will take it as root 3 by 2A whole square, A square plus B square is 20 whole square minus 2 into A into B plus A square by 4. Okay, na? Next, 400 equals 3A square by 4 plus 400 minus 20 root 3A plus A square by 4. We require the side of an equilateral triangle, that is the length of the telephone toy thread. So now we cancel 400. What we get? 20 root 3A equals 3A square by 4 plus A square by 4. So only thing you should keep in mind, altitude of an equilateral triangle is root 3 by 2A. How it is, you are going to study in Heron's formula chapter. So now what you get? 20 root 3A equals 4A square by 4, cancel. 20 root 3A equals A square, cancelling this, A equals 20 root 3. This is the answer. That is, length of the toy telephone is 20 root 3 meter. So first of all, here you have to consider this OD distance as AD minus OA, because AD has A term, OA has the radius of the circle, so we can easily substitute. If I take OD only, that is not the required part which are present in the question, that we are using it and equalizing. You can find A, that is nothing but length of the toy, or the distance between the three students or three friends. Okay, na? Take it out. These are the two statement question in the textbook. I will explain once again. Since three boys are sitting in equidistance, while joining it becomes an equilateral triangle. When it is an equilateral triangle, if I draw AD passing through the center, it is perpendicular to the base ST. That will be the altitude of an equilateral triangle. Considering side of an equilateral triangle as A and altitude bisects the base, therefore SD will be half of the side, that is A by 2. Are you all listening to the explanation? Please. Now consider triangle SOD. In SOD, we have OD, SD and OS. OS has the value 20, that is radius of the circle. SD has the value A by 2, half of the side of the equilateral triangle. But OD doesn't have any value, but we can consider OD as AD minus OA, where AD is altitude of an equilateral triangle, OA is radius of the circle. Then you will get root 3 by 2A minus 20. That is OD. So OD can be taken as AD minus OA. Then expanded A square plus B square minus 2AB. And cancelling 400 from LHS and RHS. Then equating the leftover part, adding this result, finally we got the measure of A, that is side of an equilateral triangle, that is nothing but 2 times we have taken D. You can change the letter, otherwise you can make it as it is. OD is not the radius. It is not joining from the center to the circumference. It is just joining to the point on the chord. It is not the radius. OA is the radius. Okay, na? Yes. Next question. Find the measure of angle. Find the measure of angle BCD. Get the figure. In figure, angle ABD get the figure. In figure, angle ABD 70 degree, angle ADB 30 degree. Find the measure of BCD. BD is not the diameter. They didn't inform in the question. Just get the figure, calculate angle BAD. Once you know the measure of angle BAD, then BCD will be 180 minus angle BAD. I have given the clue. Get the figure. Taken the figure. Answer. In triangle ABD, angle BAD equals 180 degree minus angle ABD plus angle ADB. Using angle sum property, we can have angle BAD. Once you know angle BAD, we can find out angle BCD, find out measure of BCD. Angle BAD equals 180 degree minus 70 degree plus 30 degree, 180 degree minus 100 degree, it is 8 degree. Next, what is the next procedure we have to do? ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. So when it is cyclic quadrilateral, sum of the opposite angles, that is angle BAD plus angle BCD equals 180 degree. Write the reason. Sum of the opposite angles of cyclic quadrilateral. Then here you write 80 degree plus angle BCD equals 180 degree. Angle BCD equals 100 degree. Is clear? Such type of questions we have done already many times. Just to recall the property I inserted this question. Over. Next question. In figure, I'll give you the figure. Angle ABC equals 25 degree. Find angle AOC. In figure, angle ABC equals, you already done this type of question, AOC, ABC What is the measure of angle AOC? In figure, if angle ABC equals 25 degree, then find angle AOC. What is the measure of angle AOC? It is 50 degree. Write the reason. Angle AOC equals 2 times angle ABC, that is 2 into 25 degree is 50 degree. Write the reason in the bracket. Theorem 10.8. Yes, central angle theorem. Just give me the answer orally. An equilateral triangle ABC is inscribed in a circle with center O. Find the measure of angle BOC. Immediate answer I require. An equilateral triangle ABC is inscribed in a circle with center O. Find the measure of angle BOC. No. What, Grishma, you are also telling the same answer? Huh? Can't you listen the question properly? How come when it is an equilateral angle at the circumference is 60 degree? What about the angle at the center? This is the question figure. Equilateral triangle ABC inscribed in a circle with center O. Come on. When it is an equilateral triangle, this is 60 degree. What about this? It will be 120 degree. Is that also 60 degree? Who is telling 12 degree? It is 120 degree. Write the reason. BOC equal 2 times angle BAC. Okay, Danya, you are right, 120 degree. Write the reason. See, circle chapter properties are many. You have to repeat what I have given the statements, think points to remember. Repeat it again and again. Okay? Is it clear? So this concludes your circle chapter. Tomorrow in my class I will do between 4 to 5. Don't again ask me. I will clearly give off all the instruction. Tomorrow at 4 o'clock you have interaction class in the Google Meet. Get ready with your book and I will go with number system. If there is any chance of doing the irrational number construction, that also I will proceed. So get with your instruments ready for the tomorrow's revision class. Okay, na? Tomorrow. And don't come to my place 1 week because this area has been attacked with the corona. So don't take the risk of coming over till next week. Next Sunday, till next Sunday, don't come near my place. Those are already given. Let it be with me only. After 1 week, you can come over and take back your book. Okay? Thank you, children. We'll see you in tomorrow's class at 4 o'clock.